Okay, Hadoop, as I told you, is a combination of two different things. I mean, it is solve the problem statement that is happening in the traditional ecosystem. The two major problem statement. One is storage, another one is processing. You can see side A and side B. So are you able to see? It's an elephant because I have introduced in my first class the brand ambassador of the Hadoop is nothing but our mota bhai. Don't say elephant, our mota bhai, right? So the mota bhai ka jo face hai, the face of the mota bhai is called the storage and processing part, the back side, you can see the processing part. So Hadoop is meant for to solve two different problem statement. One is for storage, one is for processing. Now guys, Hadoop again, based upon the version, is divided into two different categories. One is Hadoop 1.x and Hadoop 2.x. In Hadoop 1.x, there was two different things was there, HDFS and MapReduce. I have told you, right? To solve the storage problem, we are using the HDFS, Hadoop Distributed File System. To solve the problem of processing part, we are using MR, that is MapReduce, which I have already explained before break in my whiteboard. Now, there were certain limitations were there in MapReduce. What was that I explained? That was overcome by another efficient processing engine that is called YAN. And YAN introduced in Hadoop 2.0 onwards. That's why in the Hadoop 2.0 onwards, we are using two different components. One is HDFS and a YAN. There is no concept of MapReduce in Hadoop 2.0 onwards. Clear, guys? Any doubts so far? Any doubts so far? And what is the full form of HDFS? As already we have seen, Hadoop Distributed File System. And what is the full form of YARN? Yet another resource negotiator, which is taking care of resource allocation plus processing part. It is not only taking care of processing part, guys. That's why I'm telling you it's much more faster because in case of MapReduce, it's just taking care of processing part. But in case of YARN, you maybe think that YARN is the replacement of MapReduce. No, 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 no. YARN is not the replacement of MapReduce. YARN is much more faster and efficient than MapReduce. That means whatever MapReduce is doing, same task YARN also doing, but in addition to that, some extra thing is doing which MapReduce was not doing previously. That is nothing but resource allocation. So how resources will be allocated and all that thing, everything we'll see in the upcoming classes in depth. Nothing to be worried. Don't only explain the what is task tracker, what is a job tracker and all. Okay, clear, guys? Clear. Now Hadoop architecture. We'll explain Hadoop architecture. Okay, as we all know, Hadoop is a framework. Let me maximize it. Written in Java, utilizes a large cluster of commodity hardware to maintain and store big size data. Hadoop works on MapReduce programming algorithm that was introduced by Google initially, as I told you, right? Today, lots of big brand companies are using Hadoop in their organization to deal with big data. Example, Facebook, Yahoo, Netflix, eBay, etc. Right? The Hadoop architecture mainly consists of four different components. First one is MapReduce and HDFS, we have already seen, and extensively we'll see going forward. Don't worry about that. Don't think that Hadoop MapReduce means completed. No, no, no. I'm just introducing today's just name. There is a dedicated class for HDFS, dedicated class for MapReduce, YARN, and everything. Don't worry about that. Then third one is YARN, yet another resource negotiator, and fourth one is common utility or Hadoop, common utility library basically, which is used to bridge between different, third-party tool and all. Let's try to understand what is talking about. Okay, let me come back to my whiteboard. Let me explain. So, what is telling, guys? So, as you have seen, let me just give the introduction part. Everything let me complete, then come to yeah. So, Hadoop we have seen. In case of Hadoop, it is famous for two different version. One is Hadoop 1.x. Another one is called Hadoop 2.x. Guys, what do you mean by x? So, okay, let me tell you. So, not to confuse you, what do you mean by x? See, generally, any software, company or market or any product, think about that. So generally they first launch, okay, let's say any let's say Android software or whatever, let's say 1.0, then 1.1, 1.2, 1.3, then 1.9, like then after that something like the 2.0, right? So 2.0, so 2.0, then 2.1, then 2.2, something like that, like 2.9, then some 10, or then 3 will come. So instead of writing Hadoop 1.0, 1.1, I'm just writing x. Means before decimal value, 1 is fixed. That's why I'm writing x, 1. After decimal, whether it is 1.0 or 1.9, 1.5 does not matter. So Hadoop 1.x onwards. Okay, in Hadoop 1.x, two things was there. Two things was there. What is those? It's called HDFS plus MapReduce, which I have already clearly told you here. To solve the storage problem, we are using HDFS. To solve the processing part, we are using MAP or MapReduce. Clear? But Hadoop 2.x onwards, anyhow, for storing purpose, they are using the same HDFS. There is no change in that because this is super powerful. But they figure it out. There are a lot of limitations are there. Loopholes are there in the MapReduce. That's why they have introduced another component called YARN, YARN, which is the subject line or the heading or the topic that we need to enter. Yeah. Okay, then if somebody will ask, when yarn introduced into the picture, is it in Hadoop 1.x or Hadoop 2.x? No, sir, it is in Hadoop 2.x. There is no concept of yarn in Hadoop 1.x. It was introduced in Hadoop 2.x onwards. Okay, okay. And what is doing? We know already. We know already. So generally, this is for storage, and this is for processing. Storage plus processing. So here also same like HDFS is for storage plus you may think that Sun Yan is doing for same na processing. No, it is not doing processing. In addition to processing, it is also doing a resource allocation. Resource allocation. Okay, and why? What is the loopholes are there in the MapReduce? Let's discuss about that. Okay, before into the yarn, give me some idea about the MapReduce. In the extensive class itself, I will explain one more time. Okay, I'm just going through the overall idea. Just give me some overall idea. Okay, MapReduce. Then we enter into yeah. Guys, you know this MapReduce is the combination of two different things, two different operation. One is called map, another is called reduce. We'll extensively see in the upcoming classes. Nothing to be worried. Map and reduce. I mean, this is a separate task together, altogether. This is a separate task. Let's say task 1. This is a task 2. That means whenever you are doing, I'm implementing a MapReduce to process. That means it should go through this different task, task 1, task 2. It cannot avoid. First of all. Second one is, guys, MapReduce is written in the by using Java programming language. By using Java programming language. And Java programming language is a little bit complex or tough compared to the other programming language. Tough in the sense, for example, I want to write a hello world. Simply write a hello world, or you want to print your name. In Python, what happens? Just simply you write, print statement, like inside the print. Like suppose print, I will write. Let's say what? Let's say India. Okay, it will print simply India. But in Java, just to print India, you cannot write just print statement. You have to write, okay, class, some class name you have to give, curly bracket started, public static void main, then you have to pass args argument you have to pass, then curly bracket started, you have to write system out println, system.out.println, then you have to pass India, india India, then you have to give semicolon, then you have to close this curly bracket, and you have to close another curly bracket which is the class label. So just to print India, you are writing one, two, three, four, five. Let's say five different lines of code just to print India. How stupid is it? Tell me. So length of the code is increased or not? Five lines of code I have to write just to print India. But in case of Python, simply I'm writing print India. That's enough. That is why we call it as bit complex. I have to write many lines of code to do the same task, which I can achieve by using other programming language by writing just few lines of code or one, two lines of code. That's why it's heavy. As I'm writing lot of lines of code, when it will run on top of the server, it will take a lot of time, time consuming process. Efficiency is not that much great. That is the reason why these are the loophole, right? Efficiency is not good. Efficient, efficient, not efficiency, I can say, or efficient, not efficient, not efficient. Okay, not efficient. And it should have to go a typical two different process, that is mapper and reducer. And these are main task, but inside there a lot of subtasks are there. Like we have something called combiner, we have reducer, lot of things are there. That I'll show you the diagram. You'll get a much more clarity. That is the reason why they have introduced another beautiful component of yarn, of a processing part that is called yarn in Hadoop 2.0 onwards. Now, till now, we have seen three beautiful components of Hadoop, that is HDFS, MapReduce, yarn. Sir, is it like only these three components are there in Hadoop? No. Guys, lot of components are there, but let me introduce officially. Majorly, four components we have highlighted, okay, as part of the important component of Hadoop. So if you write Hadoop, so four major component. First one is HDFS, Hadoop distributed file system for storing. Second one is MapReduce for processing part. They have introduced in Hadoop 1.x onwards, which they have overcome the issue by using called yarn, and another is for utility classes, utility libraries. What is utility library? I will explain through the example, nothing to do it. Okay, guys, clear? Any doubts so far? Any doubts so far? Any doubts so far, guys? Guys, for example, okay, let me explain in this way. If I'll tell, let's say there is a class file called, let me use the black color, yeah. So abc.java, okay, abc.java file, and I'll tell another is, let's say, pqr.java file. So this is Java file, abc.java. This is another Java file, pqr.java file. I mean, if you don't know Java, that's fine. But people who know Java generally, while storing the Java file, we are storing with the extension called Java. Any file name, it may be employee.java, order.java, customer.java. I'm just taking some name, abc.java and pqr.java. So if I tell Can I make connection between these two Java files? I mean, can they interact with each other? Happily they can interact. Why? Because as both are belongs to the same programming language. I mean, ABC is written in Java programming language. PQ are also written in Java programming language. Happily they can talk with each other. No problem at all. Okay. Similarly, if I tell, let's say, there is a file called abc.py, means Python file, abc.py. Another one is called, let's say, pqr.py, pqr.py. Can they talk with each other? Or happily they can talk with each other. Why? Because they belong to same programming language. Both are written in the same programming language, Python programming language. Okay, fantastic. If I tell, sir, I have something called abc.scala. Scala is also programming language, right? Similarly, pqr.scala. Sir, can they talk with each other? Sir, happily they can talk with each other. No doubt at all. Happily they can talk with each other. Because both ABC and PQ are written in the same programming languages. But where the problem will come, the challenging issue will come, for example, one of my file is written, let's say, abc.python, py. Another file, let's say pqr file is written, let's say, Java. Sir, is it possible that they can talk with each other? Sir, this is not possible directly. Very difficult. Why? ABC is written in one programming language, that is Python. PQ is written in another programming language called Java. So they cannot talk with each other. It's a very challenging and complex task. Then how to achieve that? But I want to establish the connection between those two files. How to do that? For that, you need a third party tool or utility library or utility jar file, which will work as a mediator, or I can say kind of bridge between these two different files, so that happily they can talk with each other through this. Happily they can talk with each other this one. Then what is that file? That file is nothing but generally we call as a jar file, or we call it as utility file, utility file, or we call it as helper class, helper, helper class, or helper jar file, helper class. So whatever you are seeing here, utility library is nothing but kind of jar file or helper file or utility file which will help us to make the established connection between the Hadoop ecosystem as well as any third party tool. Sir, please could you please give me an example? Obviously, I can give you example. Here in this case, the library that I used to make the established connection between the Python file and Java file is nothing but in short we call it as, so it is a Python, right? Python, Python, Python. Okay, I have to use a jar file Python for Java. The jar file name is called Python for Java jar file. But the name is too lengthy, right? So scientists they always do prefer to use some shortcut name. So they just take some shortcut name for that Python for Java file as okay. Let me pick the first two words, that is Python, Python. Okay, Java. I just have written J because first one. So for is nothing but English for 5 4 J, Python for Java file, Py 4J jar file. So this is available in the market. You might have heard. So there is a jar file called Py 4J. What is the work of that? It is used as a utility file or jar file to make the established connection between a Python class as well as a Java class or Python file and Java file so that they can communicate with each other. That is called utility file. So this is the best example of a utility file to make the connection between a Python file and Java file. Similarly, in Hadoop also, there is a separate component present which contains library like this. Lot of different library, utility library or jar file or helper jar file, which help us to integrate with any other third-party tool with Hadoop. For example, I want to integrate with, for example, Cassandra with Hadoop. Okay, for that you have to use the jar file. For example, I want to integrate MySQL with Hadoop. Yes, you can do that. I want to integrate Tableau with Hadoop. Yes, you can do that. I want to integrate some other tool, a third-party tool with Hadoop. Yes, we can do that. But how to do that? Directly you cannot integrate. You have to integrate by using the utility jar file and all. That is the why. That is why there is a separate component called utility library. Guys, clear? Any doubts so far? Any doubts so far? Please let me know. So these are the typical four different component of Hadoop ecosystem. I have something called HDFS, then I have something called MapReduce, then I have something called Yarn, then I have something called Hadoop command, that is utility jar file. So HDFS is used for distributed storage. MapReduce is used for distributed processing. It is solve the problem statement of processing part that we are seeing in the traditional ecosystem. And yarn, the full form of yarn is yet another resource negotiator, which is taking care of not only the processing part but also resource manager, job scheduling, and all. Lot many things is taking care. And what's about the Hadoop command? Is nothing but the Java library and utility JavaScript or utility or helper class, utility library or mediator, whatever you call it as. Okay. Now let's move. High level architecture of a Hadoop. See, it's a beautiful diagram. Start of my today's class only, I have introduced a master slave architecture. So this is a typical diagram of a master slave architecture, how it looks. You can see I have something called master node. And I have lot of slave node. You can see slave 1, slave 2, slave 3, and so many slaves are there. But always one master node. And that master node, inside the master node, we have something called name node. So we call it as master node or name node, all are the same. Similarly, inside the slave node, we have something called data node. Data node 1, data node 2, data node 3, and all. And what is a resource manager? As we have introduced Yarn in Hadoop 2.x onwards. That's why there is a resource manager which will take care of the resource allocation, job scheduling, as well as processing part. And here, like how each resource manager is there, we have something called node manager here. Node manager. And here you can see the Hadoop, sorry, the MapReduce, I told you, right? So MapReduce is nothing but a combination of two different tasks. One is a map task and reduce task. So each task will be executed in separate data node based upon the memory utilization and assignment that is taken care by the resource manager. That will extensively understand going forward in the upcoming classes. Clear, guys? Any doubt so far? And you can see each node are controlled by the master node. Means master node or name node is controlling all the data node. You can see connection, right? Clear, guys? Any doubt so far? Any doubt so far? Now, next. Hadoop common or common utility. What is that? I have already explained extensively, but just have a look into this. What is written here? Hadoop common or common utilities are nothing but our Java library and Java files, or we can say the JavaScript that we need for all the other components present in the Hadoop cluster. These utilities are used by HDFS, Yarn, and MapReduce for running the cluster. Hadoop common verify that hardware failure in a Hadoop cluster is common, so it needs to be solved automatically in software by Hadoop framework itself. Okay, so I have explained what is the use of a common or utility jar file. Now we can see typically how a MapReduce program looks like. Whenever we submit a MapReduce program through client, as I told you, MapReduce is a combination of two different tasks altogether. Map task, another one is called reduce task. Map task, another one is called reduce task. Then once everything will complete, lot of hangama, everything is going on, that will see the extensive dedicated class of the MapReduce. We'll see a lot of things will come in between this. It's not like that only map and reducer. In between that, a lot of things are there. We have reducer, we have combiner, we have a lot many things. Okay, writer, reader, everything we'll see. Okay, then we'll compile the output. Finally, we'll get the output which is stored on top of the HDFS only. Because where data will be stored, the ultimate storage device is nothing but HDFS, Hadoop Distributed File System. Only the MapReduce part, this part is taking care of the processing part. But coming to storage, anyhow, we have to rely on HDFS only. Guys, any doubt so far? Please let me know. Any doubt so far? Now let's move. You can see how a typical MapReduce program is working behind the scene. Try to understand, this is very, very important. Think about, I am giving an input file. Okay, my input file contains coding, certain word, or think about this a kind of paragraph or sentence and all. Okay, think about this a paragraph or sentence and all. Coding, ice, jamming, river, driving, ice, man, ice, jamming. Okay, now what happens? I will split this input file, or basically what I am doing, I am extracting each and every sentence from that input file. Think about, this is my first sentence, this is second sentence, this is third sentence, or statement, whatever you call. I'm splitting into all different three. So three statements are there, or sentences are there. So I'm just taking three different ones. Fine. Now, think about the first one. Now, in case of mapping, what happens? I'm trying to split each and every word and trying to figure it out how many times it is repeated. So coding is repeated, how many times is present? One time. So I'm writing coding, comma, one. Then ice, how many times? In this only. Don't look into this. I'm talking about this only. First sentence only. Ice, one time. Then jamming, one time. Similarly, river, one time. Driving, one time. Ice, one time. Here, in this statement only. Similarly, in this statement, man, one time. Ice, one time. Jamming, one time. Clear? Now what happens? In between mapping and reducing, which is taking care of mapper and reducer, we have something called shuffling. Now, whatever the input you are seeing in this mapping, it will be jumbled up or shuffled. So, for which the key is the same. So, before comma, this is key. After comma, this is called value. Wherever you will see the coding, that related value will come into the picture. Now, let me figure it out. Let me explain, then you will get to know. For example, coding. So, I'm writing coding, comma, one. Is there any other coding present in this? No. Here, no. So, I'm writing coding, one. Fantastic. Now, come to ice. So, first I'm writing ice, comma, one. Okay. Any ice present here? Yes, one ice present here. So, I have to write 1, comma, 1. Because first one is for this one. Second one is for this one. Then third one is for this one, because another ice also present here. So if you count ice 1, ice 1, ice 1, 3 times ice is repeated. That's why I'm writing ice 1, comma 1, comma 1. Similarly, let's take another example. Suppose jamming. Jamming present one time, okay. Not present, here not present. then present here. So how many times jamming present? 2 times. So can I write jamming 1 comma 1? Yeah, that's why I written 1 comma 1. If you say river, so river not present here, not present here. So only one time present. That's why I written river 1. Similarly, man, not present here, not present here, present here. I've written man 1. Similarly, driving, not present here, only one time, not present here. So driving 1. Now reducing. So I want to reduce it. Reduce means sum it of the entire value. So coding 1 is present. So no doubt coding 1. Ice. How many 1 is present? 1, 1, 1. Can I add it up? 1 plus 1 plus 1. That's 3. So I'm writing ice comma 3. Then jamming 1 comma 1. So 1 plus 1 is equal to 2. I'm writing 2. Then river 1. Okay, river 1. Then man 1. Then driving 1. That's all. Then as a final output, I want to store into a file. So in the file, I'm cropping all the individual output into a single file. That is coding 1, is 3, jamming 2, river 1, man 1, driving 1. That's all. But whenever guys will run a MapReduce program, will not able to see all this. Behind the scene, the architecture is working like this. See how complex it is. I'm just making you comfortable or explaining the backend architecture or backend the flow, how it is running actually. But whenever you will execute as a program, you will not able to see such type of hangama on the screen itself. Just give the input, after some time you get the output. You are giving this input file, you are running your MapReduce program, you are getting this output file. You are happy, oh, that's great. That means coding present 1 time, is present 3 times, jamming present 2 times. Generally, people ask such type of question. They will give a, let's say, PDF file or maybe Word file. They will tell, figure it out each word repeated how many times. Give me the word along with its count. So if you pass for the MapReduce program to this MapReduce program, you will get such type of output. But it looks very easy. But behind the scene, all this hangama is going on. That is something called splitting, something called mapping, something called suppling, something called reducing. Guys, clear. Any doubt so far? Any doubt so far? Guys, in Hadoop, we're using a lot of configuration file. When you will do the practicals, you'll see a lot of configuration file you are using as part of the environment setup or day-to-day activity to run any jobs. What are those? I'm just reading most most of the frequent configuration file that we used. One is something called Hadoop-env.sh. Env stands for environment file. Environment variables that are used in the script to run Hadoop. Okay, that is called Hadoop-env.sh means script file. Similarly, core-site.xml file. This file generally we used configuration, setting for Hadoop core, such as IO setting. IO means input output settings that are common to HDFS and MapReduce. Similarly, another XML file or configuration file we use that is called hdfs-site.xml file. This configuration file setting for Hadoop, demands the name node, the secondary name node, data node, and all. Basically, the memory size and how many we have to use. Okay. Then similarly, another one is called MapRed-site.xml. Means MapReduce. In short, I'm writing MapReduce. So MapRed-site.xml file. This configuration file setting for MapReduce daemon, the job tracker, the task tracker, and all. Each and everything we'll discuss going forward. Okay. Now, we have something called masters, a list of machine, one per line that each run a secondary name node. So this is a master node. And slave node, a list of machine, one per line that each run a data node and a task tracker. So generally, the task tracker is running inside the slave node, and I can say job tracker. Okay, job tracker is running inside the master task tracker and job tracker. Okay. Fine, clear. These are the typical. So 1, 2, 3, 4 a file or configuration file that we use as part of the environment setup of the Hadoop configuration file. Now, yet another resource negotiator. Yarn is a framework on which MapReduce work. Yarn performs two operations that are job scheduling and resource management. We have seen sometimes before. The purpose of job scheduler is to divide a big task into smaller jobs so that each job so that each job can be assigned to various slaves in a Hadoop cluster and processing can be maximized. Job scheduler also keep track of which job is important, which job has more priority, dependencies between the job and all other information like job timing, etc. As the use of resource manager is to manage all the resources that are made available for running a Hadoop cluster. So these are the typical feature of the yarn, that is multi, tenacity, scalability, cluster utilization, compatibility. These are the typical features of yarn which are not available in case of MapReduce. Clear, guys. Any doubts so far? Any doubts so far? Now, these are the typical list of yarn components. Anyhow, that I will explain in my whiteboard. Let's come back to my whiteboard first. Okay. So we have already started the yarn. What is the full form of yarn? Let me write down here itself. Yet, yet another resource negotiator. Yet another resource negotiator, guys. Okay. So we have already seen. Is that? Yeah. So as part of Hadoop 2.x onwards, we are introducing a beautiful component which is not only, I cannot say replacement of MapReduce, but yeah, efficient than MapReduce, which is taking care of processing as well as resource allocation, as well as job scheduling also, I can say job scheduling. Job scheduling. SCHADULING, job scheduling. Okay. Now, coming to the yarn, guys, I will also introduce a few more terminology which is related to yarn. Coming to yarn, guys, YARN. Okay. We have something called resource manager. And another major component is called node manager. And what is the work of this resource manager? The work of resource manager is to manage the resources that they have to assign to each and every node or slave. And this node manager is nothing but whatever the task you will assign to a node manager, that will take care. Like whether this task are properly working or not, any particular application master is working or they goes down, each and everything they will take care. So this resource manager is generally resides inside the name node only. Name node only. Name node. And this node manager resides inside the data node only. Data node. And again, to do the task in the name node, we have something called job tracker. This is called task tracker. This is called job tracker. Because whenever you are submitting a job, it will split into different task altogether. different stages. Then from stage it will split into different tasks. So it is something like that. Let me just draw a beautiful diagram for that. Whenever you are submitting a job, for example, this is your job. Okay, and I can say, okay, multiple stages will be there. Okay, then let me draw it. Then I'll note down all the labeling. Let it be. Okay. So now this is called, this is my job. J O P, job. This is my stage. This is my stage. This is my stage. So this is my, let's say, stage one. Obviously, this is stage two, stage three. This is my stage four, stage five, stage six. Okay. So whenever I'm giving a submitting a job, the job will split it into different stages altogether. Different stages altogether. Then each stage will be split into different tasks. Different tasks. Think about for this one also. So let me use a different color. Which color I'll use? Okay. Will it be visible? Okay. So let's say this one, this one, this one, right? And for the middle one, let me use a different color. This one, this one, this one. So each are called as tasks. So let's say T1, T2, T3, T4, T5, T6, T8, T9, T10, T11, T12, T13, T14, T15. Obviously, it will also interlink. Don't think that this is also not linked, right? Also split. So basically, this is job, this is stage, and this is task. Task. Okay. So basically, this task will be running inside the name node only, data node only. And this job, the job tracker will be taking care about the job, it is running inside the name node. So guys, in the past, in the introduction class itself, I mean the today's first initial time, whenever I have given lot of naming convention. So now we can add few more things with the existing one. That means with this, let's say I'll pick the first one. Think about the first one. I'm renaming. I'm writing one more time. Okay. So first, so I can write now as a final synonyms. That is, we call it as, let's say, master or name node, or we call it as resource manager, or we call it as, what is that, job tracker. That means I can say in the master node, resource manager exists, job tracker exists, name node also present in the master node. Similarly, like master, I can write slave node. Slave node. In slave node, what is present? For name node, I can say data node present. Data node present, which I have already written on the top also. Data node present. What is the data node? Yeah, data node present, right? Then we call it as worker node or resource manager. I can say exactly a resource manager, that is called node manager. Then exact opposite of job tracker is nothing but task tracker. In addition, there are some other few names we also giving here, like worker node, right? So worker node also we call it as. Okay, so master node or slave node all are the same. So don't be confused. If somebody is telling, you should understand, okay, this is master and slave. This is name node, data node. This is resource manager, node manager. This is job tracker, task tracker. Okay, job tracker, task tracker. Then we have something called worker node altogether. Clear, guys? Any doubts so far? Any doubts so far? Similarly, we have also given other name. That is what? Second hand name node is second hand name node. There is no other name for second hand name node. Clear, guys? Any doubts so far? Any doubts so far? And this resource manager and node manager introduced in the yarn itself, because there is no concept in Hadoop 1.x onwards. This resource manager and node manager introduced in Hadoop 2.x onwards. But there is a concept called master node and slave node in the Hadoop 1.x, name node and data node Hadoop 1.x. But resource manager, node manager, task tracker, job tracker, these things introduced in Hadoop 2.x onwards. Let me write them also. That will be very helpful for you people. Okay. These are the cream things, guys. Okay, this is Hadoop 1.x onwards. This is Hadoop 2.x onwards. 2.x onwards. Clear, guys? Any doubt? Any doubt so far? Any doubt so far? In addition to resource manager and node manager, we have something called application master and we have something called container. Then what is the work of that? Let's try to understand. Application master, it controls the user job lifecycle and resource demand of single application. It works with the node manager and monitor the execution of the task. Similarly, what is the work of container? It is the combination of resources including RAM, CPU, network, a hard disk, etc. on a single node. Basically, container is nothing but kind of think about a place where actually you will submit the task and task will be running or executing, I can say. And that will be taken care by the application master, because application master is nothing but the name itself is telling master. So master of what? Application. So whether your job is running, often running fine or not, that is just monitoring. So that is the work of application master. Then what is the node manager? It runs on the slave daemon or slave node, as I told you, right? And executes a task on each single data node. Because this node manager resides inside the data node, which is nothing but inside the slave node only or worker node only, which executes a task on single machine because it's taking care of the task management. Coming to resource manager, it runs on the master daemon or name node, I can say, and control the resource allocation in the cluster. So resource manager is taking care of the resource allocation in the cluster. Node manager is taking care of the execution of the task in each single data node. Then who will actually observe it, who will actually just see it, watch it. That is application master. Where it will execute the task and all inside the container only. Now I hope you got a clear cut picture. Now you can see a clear cut diagram for this. Whenever the client machine or edge machine, you are submitting your job to the resource manager, which resides inside the name node or master node. Now, your node manager present inside the slave node or data node or worker node. All are the same name. Naming convention we have already seen, right? Inside that we have something called container, inside which actual the task will be executed. And who will take care of that? That is nothing but the application master. So inside worker node or name node, data node, we have something called application master container that will be always there. You can see the orange color mark I have given, job submission. So job I have submitted from the client node. Node status. So once whether the particular task is off and running fine or not, it's got completed or 50% completed or 30% completed or 95% completed, that status node manager will give back to my resource manager. That's why you can see this point, right? This arrow mark, this color arrow mark, node status, whether a particular node, data node is working fine or not, or is just go to the dead state. Okay, then resource request. Application master will request to the resource manager, hey, I need 4 resources, but only 2 resources are there available, readily available. Could you please allocate another 2 resources? That will be taken care by the resource manager. But who will request? Application master. Similarly, MapReduce status. Okay, you can see. So dotted mark. This is the MapReduce status. Because MapReduce means mapper task and reducer task will be executed inside the container. So that status will be given by this dotted line. You can see from container to application master. Then from application master will request whether they need more resource or not to the resource manager. I hope now you got a clear-cut picture how it will work actually. Guys, clear. Any doubts so far? Any doubts so far? Now, yeah, already we have completed this one. YARN stands for yet another resource negotiator and it belongs to Apache Hadoop technology. To put it simply, it is a large-scale distributed operating system for big data application. The benefits of this is that it enables Hadoop to support more, varied processing approaches and a broader array of applications, such as the Hadoop clusters now being able to run interactive querying and streaming data application along with MapReduce batch jobs. Clear, guys. The technology is designed for cluster management, and is one of the key features is the second generation of Hadoop, the Apache Software Foundation open source distributed processing framework. YARN is a software rewrite that is capable of decoupling MapReduce resource management and scheduling capabilities from the data processing component. In its structure, the processing component is separated from the resource management one. Basically, YARN helps the information stored in the Hadoop distributed file system (HDFS) to be run by different data processing engines. Clear, guys. Any doubts so far? Any doubts? Apache Spark, then MapReduce we have seen, then Apache Impala, Apache Hive, Apache Mahout, Peak, and HBase. Anyhow, and all things are not important. The important concept we will cover. So as part of important concept, we will cover MapReduce, we will cover HBase also, we will cover Hive also, we will cover Apache Spark also. Okay, these are the important tools that will cover. Anyhow, so other tools like YARN and other things also, HDFS, everything also. HDFS is not mentioned here. That also we are covering. Clear, guys. Any doubts so far? Any doubts so far? Let's come back to our whiteboard. I hope all of you are able to see my screen. Yeah, you can see. So these are the naming conventions that we have written here and we need to follow going forward in our each and every classes. This is very, 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 very important, I can say. These are the terminology. Okay, very, very important. Okay, now let's move. Let's proceed further. Let's see. Is there anything left? Yeah. So we have successfully completed the yarn. Okay. Then we have seen the task processing in Hadoop. Okay. How task is getting processed. Okay. So I have told you, right? So resource manager, then is giving signal to node manager, and node manager interacting with the container as well as application master, right? Application master, and that is present in one single worker node. Similarly, we have multiple worker node as well, and this is present in the name node altogether, right? They are interacting with each other. Okay, and we have some client machine also there, which is sending the job. And we have seen also different tools for Hadoop. Different tools for Hadoop. Let me just write down officially the tools for Hadoop. Tools for Hadoop. Okay, so we'll see something like that. Obviously, I mean HDFS we have already seen. Going forward, we'll see in depth. Then MapReduce. Okay, then we'll see something like Hive. Then we'll see something like HBase. Then we'll see something like Spark. So these are the important tools. In addition to that, which is already legacy, but it's again still part of the Hadoop tool only. We have something called Peak, which initially people were using when it was introduced. Then Impala and all. Impala, Impala. Okay, Impala and all. But anyhow, this is not that much, popular nowadays. People are not using. And Impala or Hue or Hive, or sometimes we call it as Hue. That is the editor by using which I can write SQL query, Hue, Hive user interface. Okay, and it is also not that much important. Okay, we are not going to discuss. We are going to discuss all this as part of our classes, upcoming classes. Okay, important. Clear, guys? Any doubt so far? Any doubt so far? If not, yeah. So successfully, why we have completed today's agenda, whatever we have set to cover as part of today's class. And with this, we have successfully completed the introduction to Hadoop as well. So in the upcoming classes, we'll see what are the other things like maybe HDFS or MapReduce, whatever will come. I'll see the curriculum, and according to that, I will start accordingly. Clear, guys? Any doubts so far? Please let me know. Any doubts so far?